Hi, this is Steve Mitchell. This is part one of two, dealing with paleosols and how they relate to the global flood. I ended up making it longer than I originally planned to, and so this will be part one, and part two will cover the rest of it. The first part's going to look at how young Earth creationists model the time that it took to deposit different rocks, particularly the rocks that were involved in Noah's flood and those after that. And given the rates of deposition that these predictions demand, then we can use that to evaluate some of these models based on what we find in the rock record about soils and ancient soils, paleosols. We'll look at a few examples from around the world. And then I'm going to introduce the Llano Estacado in eastern New Mexico and West Texas. And I'll talk more about that in more detail in the next video. Welcome. I'm Steve Mitchell. I'm a Christian geologist, and we'll make a video to look at this question: do the rocks that we found in nature support the young Earth creationist, or YAC, claim that most of the rocks on the Earth's surface were formed by Noah's flood? Most geologists, as you know, don't look at it that way. But is it possible that this was just an alternative way to look at the same data? Maybe both options could be valid, and you would have to decide which one after that. Are they both valid? Today, I will be describing a set of features and looking at how they relate to young Earth creationist position, their understanding of geology. We'll look at their interpretation. We'll be looking at some ancient soils. They're known as paleosols. Since we're looking at ancient soils, I thought about calling this digging up some old dirt on flood geology. We won't be digging too literally, and we won't be digging in the sense that some people politically use the phrase digging up dirt either. We don't want to be mean or make fun of flood geologists, but on the other hand, I do want to point out that there are a lot of unanswered questions, or often very inadequately answered questions, and that they need to resolve. Now, as for myself, I am a retired petroleum geologist. Spent a number of years looking for oil and gas in many parts of the world and developing hydrocarbon reservoirs. And it's kind of nice to be able to work in a field where you actually enjoy the work and stuff that you've been doing and just enjoy doing. I started studying rocks when I was about 5 years old, and so I've been looking at them for a long time that way. As a Christian and as a geologist, I've been asked many times, how old is the Earth? And where do you find the deposits from Noah's flood? I don't find any conflict between my faith and between what I see in the rock record and what I find in science. I find they both fit together really well. I think we can find evidence of God's hand in many places, in many ways. But I do have a problem with those who claim that the Earth was created less than 10,000 years ago, or that most of the rock record was laid down by a flood. That doesn't mean that the Earth was not created or that Noah's flood didn't happen. I certainly believe both are there, and both are evident. But it just didn't happen the way that they choose to interpret the scripture. Now, we will look at paleosols from several different parts of the world, but one of the key examples will be from West Texas and the Llano Estacado. Kind of the edge of that is kind of shown in the picture that I have behind me, which is from Palo Canyon in West Texas. We'll look at some other examples from there. You might wonder, why is it that we would find ancient paleosols or ancient soils? I mean, if the geologic processes that we have today were just to continue just the way they go for several million years, and we were able to fast forward and time travel to that type of location and dig down to see what's left of what we have today, you'd find that most of the soils that we have today would be long gone. They would have been eroded away and would not remain. But just because a lot of it would be eroded away doesn't mean that all of it would be eroded away. And we would expect to find some. I mean, after all, if the Earth is really billions of years old, the way most geologists believe that it is, not surprising, there would be places where you'd find little pieces of the paleosoil left. Sometimes they might be bigger. We ought to see evidence of lots of these things, and geologists agree with this, and in fact, believe that we do find that type of evidence. So take a look at that. You can judge for yourself, how good is the evidence, and is this something that might influence what you believe about the history of the earth? Why would we use the Llano Estacado? I'm probably biased, but I don't think there's a better example anywhere of the type of features that we're going to be looking at. I think it's pretty spectacular that way. It provides some, I might say, mammoth problems for flood geology time frame. In fact, we'll look at a big Paleosoil zone where we can see a lot about how it developed. Another bonus is it's another place, it's in a location where it actually ties to, at least in North America, it ties to some of the most important human history. That's because humans lived in the closed New Mexico area, which is on the Llano Estacado. And they do provide kind of a mammoth problem because we find mammoth bones and human artifacts at the same location. I need to go into PowerPoint and we'll take a look at some of the things there. Okay, here we are in PowerPoint. I've got my face down into the lower right. So if you want to see the speaker such as he is, you're welcome to take a look at that. But the material that I want to show will be on the slides. Again, this is entitled Paleosols and the Global Flood. And we'll look at that example out of the Llano Estacado. Okay, here are the topics that I want to cover today. We're going to look at soils in general, so we can understand what we're talking about that way. We're going to look at the time frame that young Earth creation put all of this geology to have been formed in. Then we'll look at some Paleosoil examples from around the world. Just a few, because we're going to concentrate mostly on the Llano Estacado, and in particular the Ogallala Formation there. And we'll focus a lot of attention on an upper unit in it that's made up of caliche, limestone that forms in soils. Above that, then we'll move up shallower up in the section. We'll look at the Blackwater Draw site, and this is in Clovis, New Mexico. And this is where we have mammoth bones and human artifacts together. And then we'll draw a few conclusions after that. Okay. As I said, we need to think about what is a soil. After all, we need to agree about that if we're going to talk about that type of, we kind of take for granted soils on our planet, but this is probably as far as we know, this is the only planet that has soil. They're not just weathered rock, right? They have to have more to it involved in that. According to one definition, soils are a complex mixture of minerals, water, organic matter, countless organisms that are the decaying remains of once living things. There are a lot of different types of soil. Soil scientists will characterize these and split these into different types, but they all have some different types of horizons they would recognize them. They're built on some sort of surface. It may be a bedrock. It might be some sort of an earlier soil, perhaps. But there's a section above that they would call the horizon C. And horizon C incorporates a lot of the parent material in it. It's all similar to the form that it was in the parent itself, but it's more broken up. And then you would have the topsoil, the horizon A. Horizon A is where you have most of the roots which grow down into it. And they grow in, they are chemically combined, has a lot more organic matter in it. But rainwater, as it comes through there, will filter down through this, and it will leach out some of the chemicals out of it. And that will be concentrated in the zone B. Now, if you're in a very humid area, that zone B might be highly concentrated in iron, and it might look very reddish that way. But on the other hand, if you're in a drier area, you might see more, the calcium has moved down into it, and the calcium might concentrate as calcium carbonate or lime material. And we'll look at some examples of these types of things. So the question comes, how long does it take a soil to form? How long does it take this complex mixture to develop and some of this leaching take place? And it is variable, but this is one report from online. It says that the Soil production rate due to weathering is approximately 1/10 of a millimeter per year. 1/10 of a millimeter per year. That's very slow. Weathering is a slow process. Now you can have dust deposition that can be blown in, and that can make it to be higher, and it'll gradually develop and be able to support higher forms of life. USDA has an estimate on this. They estimate that it takes natural processes, it can take 500 years to form 1 inch of topsoil. That's a pretty slow process. And of course, it's variable. There are exceptions to this. For instance, here's a report from Hawaii. It says that lava flows, which form on the rainy parts of the island, will break down and produce a soil within a couple of years. Pretty fast. Whereas lava flows, which form on the dry parts of the island, can take hundreds of years to break down and produce a soil. Local conditions are pretty important on that. Any of these rates can provide some interesting challenges for flood geology. We need to look at the predictions that they're making and see how those would impact that. So it involves looking at the time frame that's predicting. Like my young Earth, I have an old Earth model as well. Oftentimes, young Earth creationists claim that their work is not being taken seriously. But if we are to take their work seriously, then we need to be able to examine it closely, look at the predictions that they're making, and be able to test those. And the predictions that they make need to stand up. How fast do they claim that rocks were being laid down? There's some kind of speed limit that might exist for the different processes that they predict. Is there a limit to what is possible that way? So let's take a look at their predictions. So I'm going to build a set of timelines, and they're or strat columns, as you might call them as a geologist. I like these type of things because they allow you to summarize a lot of different observations and see how things relate together. Now, from a young Earth creationist interpretational standpoint, any rock that exists would have formed in one of basically 5 periods of time. And that's what I'm illustrating in this. And the oldest rocks in this would be rocks that were formed during kind of the week of creation, virtually instantaneously. And so there's really not any measure of that. They might look older because they might have been created to look old. So it's not something that you would be able to test. This in the most common models and stuff would say it took place about 4,000 BC. Some would say that it could have been 10,000 BC because it stretched the period up above that. Above that, you would find those that were deposited somewhere between creation and Noah's flood. So in the text that we have in the Masoretic text, in most of our Bibles, this would add up to be 1,656 years between Adam and Noah. And so that's a period of time. That way, someone should stress that a little bit. This would be kind of those from period 2. And then you have Noah's flood. And according to AIG, this would be in 2348 BC. This is a 1-year event, a catastrophic event. And that's where a lot of young Earth creationists would say most of the rocks were laid down. And then you're going to have, after that, you're going to have post-flood deposits. And I break these up into 2 periods. One would be the time those that developed after in the time of Abraham. So it's about 4,000 years ago when we believe Abraham out of the Bible lived. And then between that and the flood, that's about 450 years. So there would be a period of time that would be what I call the period 4, which is post-flood deposits, and then post-Abraham deposits would be those in 5. Now, most people who examine rocks and examine sediments understand approximately what the break between these is. And it doesn't have to be very precise that way. We can examine it in very general terms. And you can think of these as if you had a location where you had somehow deposition all the way from creation on. All of the rocks would be from one of these time periods, right? They would be in one of these eras, regardless of how long the eras took. In a place where they hadn't been distorted, they'd always be in the same order. So this is how the young Earth creation strat column. Let's take a look at a geological column. So the geologic column in here is now scaled in millions of years from the understanding of most geologists. But that's very different from the scaling from the young Earth creationists, where we're looking at years. But the order that the rocks are laid down in is understood in general to be the same. Most young Earth creationists who have a background in science and have examined the rock record recognize that the order is the same. It's divided into a series of periods. And we could compare those periods to the American history, for instance. You might have the colonial period, and above that, you might have the period which led up to the Civil War, and then you would have the Civil War period. And then you might have the period post-Civil War period. And those would be the type of periods that we look at. And here we're looking at geologic periods, and they all have names. We have the oldest periods are the Cambrian period and the Ordovician, Silurian, and the oldest are grouped together to be called the Paleozoic. So the Paleozoic era now has a series of periods that are recognized within that. And then up above that, you would have the Mesozoic era, and 3 periods are within it: the Triassic, the Jurassic, and the Cretaceous. And then above that, the Cenozoic era. Now, these names kind of sound strange to the non-geologist, but to a geologist, they become very simple names for a period of time and names for a rock. Most young Earth creationists who have a background in looking at the rock recognize that the periods are in the right order, regardless of how much time was involved in each of them. They would differ in the amount of time that they interpret to be taking place there, but they would not disagree with the type of order that is, and the order being valid. So now we're going to move beyond this, and we're going to shrink the text a little bit on some of these and show then what this would look like with some of the young Earth creation models. So with this, I put in a couple of the most popular and most prominent creation models that have been put together. One is by Dr. Tim Clary with ICR, that is over on the left. And then on the right, we'll have one by Dr. Andrew Snelling with AIT, or Answers in Genesis. And you notice that both of these put a darker blue section down below that. This would be what they interpret to be deposits of the rising flood from Noah's flood, and then a receding phase up above that as the waters would have been coming down. What you can see is that both of these are interpreting large amounts of the rock record to have been deposited within the 1 year period. And these are now scaled in days, so it's a very sharp contrast to what the most geologists would say, but their interpretations are also very different from one another. So you can see that the base, they interpreted about the same. They're both saying that the same rocks were always deposited in the early part of the flood. But when you get above that, it begins to be very different. The peak of the flood, they see it very differently that way. And that they would say that, for instance, Dr. Snelling would say that the peak of the flood was at the top of the Paleozoic rocks. So the flood was rising up to this point, and then it began to recede through the Mesozoic period, and then the Cenozoic period would have been all post-flood deposits. Dr. Clary, on the other hand, would say, no. Actually, what's happened is that the floodwaters were rising all the way up through the Cretaceous period, all the way up through the Mesozoic period, and then most of the Cenozoic period was also part of the receding phase. So it's kind of interesting. For instance, you could say that most of the dinosaur deposits, dinosaur tracks, and this type of thing that we have would have been formed in the receding phase, according to Dr. Snelling, and whereas they would have been deposited in the rising phase, the floodwaters were rising, according to Dr. Clary. An interesting difference in point of view, and both of them can show a lot of very valid reasons why the other one is wrong, which is, I would agree that each of them are wrong in that sense. So what I'm going to do now is we're going to take a look at how this looks in some of the more parts of this. We're going to look at some Paleosoil examples in the Devonian period. A couple of examples from that period. We're going to look at some up in the much shallower period and also some nearby the West Texas example out of the Permian period. We will look at the Llano Estacado, and I have colored in orange here the places where we have rock preserved in the Llano Estacado, although very deeply buried in most cases. But we recognize that from drilling oil wells down it. You can tell what the rocks are down that way. You can see there's some gaps in between these because there are places where either the rock has been eroded away or else it was never deposited. And we're going to look particularly up in the upper part of this. And in fact, we're going to zoom in the next slide on this interval up in here. So this will look a little bit differently, but it's really the same chart, the same pieces in that way, but only showing the upper part of it. And that'll give you a little better idea of how much difference is there. Okay, so again, we've got the flood part that's expanded out. That's zone 3 is expanded out. We've got that section 4, which is kind of in the peach colored section in here. You can see my pointer pointing out here the post-flood deposits, which are roughly 450 years of deposition at most. There's some interpretations would say that Abraham lived a little bit earlier, which would squeeze the time of that. And then you have a little wedge above that, which is the 4,000 years of deposition. And from a geologist standpoint, that the 4,000 years would be in kind of the latest Holocene. So a little bit of the late Holocene would have been deposited after the time of Abraham. The rocks of the Llano Estacado are shown in blue up in the very top of that. That's where we'll spend quite a bit of attention. Again, you see the big difference between the two interpretations that way. And it's important to realize that this rock that for instance, is differing here, which is a big part of the Cenozoic, represents very thick deposits, particularly in the Gulf of Mexico. This is many miles thick. So this is a major difference to explain. So from a geologist standpoint, that deposition looks to have normal type of river deposits and fluvial deposits, fluvial deltas and slope deposits and deep water deposits. And so it's hard to understand why you would call that the deposits from the flood, but it's very thick, so it's very difficult to imagine it having taken place in 450 years. But we're going to take a look particularly up at that upper part, and you can see that there's a section in there. So we'll have to take a look at two interpretations of that upper part to see whether that was deposited during a flood or whether that was deposited very, very quickly in the post-flood time frame. How fast would the Ogallala Formation have been deposited? Well, it takes place in Dr. Clary's model during the flood, and so maybe over the course of 30 days, it would really be very squeezed. You would have a little more time in Dr. Snelling's model, but again, if you're going to put all of the epochs in, all of the intervals in deposit within 450 years, put 2 epochs into here, could you have 200 years? I think that would be stretching it. So it's really, again, a very tight time frame, regardless of whose model you're looking at. The nice thing about the published reports from Dr. Snelling and Dr. Clary is they actually are making some actual testable predictions this way, and we can look at it and evaluate those. So let's go forward. Now let's look at the ancient soils, Paleosols. And we recognize a lot of different horizons, as we mentioned, in modern soils, and we can see the geochemical signatures associated with those. Can we be a detective? Can we recognize what would be an ancient soil with the same type of characteristics that way? Young Earth creationists recognized that you could not develop a Paleosol during the flood, because even the fast rates, the rates that we were talking about in, for instance, Hawaii or on the volcanic island, humid regions, take more than a year to develop it, and you wouldn't have a year. You'd have only a short portion of that time to deposit a particular unit within geologic record if they were deposited by a catastrophic flood. So what you would see from most young Earth creationists would say that, hey, this really wasn't soil. This was something else. So we'll take a look at how good is the evidence that these soils really exist. And it's variable. We'll just take a look at a few examples of that. One thing we might look for would be evidence of root. So I'm going to take a look at a case from New York State, and this was published in 2020 in Current Biology. It's looking at some paleosoils that were in the Devonian section, and you can see the interpretation here of many different cracks or desiccation cracks like form whenever mud dries out. You can find there are features like a lot of different roots up in through it. So are these really something that's believable? Are they firm enough? Well, here's a picture that they published. And what you see is a lot of different tree roots growing out, extending out over a long period of time. This is interpreted to be one of the earliest forests that we have preserved, or evidence of the forest that was there about 400 million years ago, almost 400 million years ago. So would this have been during and what's interpreted as a flood? Both Dr. Clary and Dr. Snelling would say that this was part of the rising waters, the early part of the flood. So would there have been time for these type of tree roots or these type of forests to grow during that early flood? I think most would say it's not. What they would have to say is that this must, in that case, be something that's really not a forest. These really aren't the tree roots. But they look pretty convincing to me. Could you transport trees in a flood? Well, let's take a look at another case. And we're going to go to an island off of Greece called Lesbos. We're going to look at Miocene examples. This would be late in the flood interval, according to Dr. Clary, and the post-flood interval by Dr. Snelling. What we're looking at here, was this deposited by a flood? Well, I think you could see a stump of a tree that has been preserved. You can see an extensive root system coming out from it. It obviously took time to grow. I don't know how you would grow a tree like this in a 1 year time period. I don't know how you would grow this in the very short time period that the late Miocene would have had to have in Dr. Snelling's time frame. Could you transport tree roots in a tree and the tree be upright during a flood? Well, as it so happens, young earth creationists like to point out that you can have transported trees, such as this example from Mount St. Helens area that was deposited in 1982. And there was a slide which moved a whole lot of material down, including transporting some trees as upright material in an area that they call Spirit Lake. And yes, you can do that. Notice that these are broken off and they show evidence that way. And the sediment that would be around this would be from a lake type of sediment, as opposed to the type of sediment from a paleosoil. And that would be what you would find in the situation in Greece. I mean, it takes some faith to believe that a tree trunk, such as the one that we see in Greece, could have been transported by the flood. It takes some faith to say that it could have grown in just a very short period of time. That might be possible in the AIG model. Okay, let's take a look at another example. In this case, we're going to go to back to the Devonian time. So in the rising flood period for these guys, this is taken from China, but it's just a nice photograph of the type of thing that we see in many intervals around the world. And what you see is some red material in it, red silts that were deposited in a continental type of setting. You know, iron can form in two different states. It can be in an oxidized state, such as this, with the ferric with the red. But you see the green down in here, coming down in vertical sections down in here. These were deposited with more of a reducing type of iron state or appearance of iron. And that comes from a reducing environment, and those formed around tree roots or around plant roots. We don't know what kind of plants they were. I think it's pretty evident there are a lot of roots in this area. And I say this type of thing has been found in many parts of the world, in many different sections. And the interpretation would be that this was a paleosol with a dense growth of plants in it. I think that's a very good interpretation. Take another look. Look at a different example, and we're going to go to Central Texas, not too far from the area where we'll be concentrating later in the Llano Estacado. See a whole bunch of sandstones in here, which are shown in yellow. We see the green areas in here, or light green, which are sands that were deposited in a kind of a relatively shelf type of setting. And then we see some limestones in blue. And it looks like definitely an area where the coastline went back and forth as the sea level, relative sea level, would go up and down in this type of area. And a lot of these systems have been mapped out in a fair amount of detail, just like you see in the photograph in the upper left. What you see is these yellow stream paths that were ancient streams which flowed down through the area. Okay. You see these red dots on the right, though. These are each recognized paleosols that have been mapped out in an article published in 2004. What we're looking at is 31 different of these. They're not all alike. They have different characteristics, but they're all very similar in the sense that they look like they're set up like a paleosol. They have the type of horizon development that you'd expect. Many of them have roots in them. A lot of the different features that you would expect to see in a soil environment. If one of them is a paleosoil, they're probably all paleosoil. I think it's very hard to make a case that none of them are. Would the youngest interpretations of this be? Well, this comes from the Permian section, Permian time. So in both Dr. Clary and Dr. Snelling's interpretations, these would have been all deposited within the rising early flood. That becomes a really hard case for me to buy. Now let's take a look at a younger example. And we are going to actually move to the Llano Estacado. Okay, this is a photograph of kind of the edge of the Llano Estacado. Llano Estacado can be translated as the staked plain. It's basically a large plateau area, also called the Southern High Plain. Big flat area with the on the rim around it and stuff. Oftentimes you'll see a pretty good escarpment, such as you can see in this photograph here that comes down. This is not too far from Amarillo, Texas. The top part of it is more resistant to erosion, and it's called the cap rock. Or when you drive off the edge of it, you're coming off the cap, as people would refer to it in that area. So we're going to move to a map view. And there's the Llano Estacado in West Texas and eastern New Mexico. You can see there's some rivers that kind of define it, with the Canadian River to the north, Pecos River to the west, and then a series of rivers that kind of are working their way into it, coming in from the east. You know, this is a large area. It has about 37,000 square miles, 97,000 square kilometers. This is larger than the state of Indiana. So if this were an independent state, this would be the 38th largest state. And it would be, it's also, if you're from Europe or someplace for this different frame of reference, this is about the size of the island of Ireland. It has a dominantly semi-arid to arid type of climate in the area, and it's a very flat area, so it's not an exciting place to drive across as far as that goes. It has some great farmland, ranch land out in the area. It's so flat that some people say, well, it looks like it's been ironed. And some of the towns in the area kind of give you a feel for what it's like. So it's a town of no trees. And for the most part, there's no trees on it. And there's also the town of level land. Very well named. It's a very level land. There's the town of Plainview. And that's pretty much what you have. It's a plain view. There are a few towns in it that are important. One is Lubbock, Texas, which is home of Texas Tech. You might be familiar with it. Amarillo, Texas is in the north. You can go to Amarillo by morning. But if you're going in New Mexico, the town I noted in here is the town of Dora. It's a large town of about 100 people. But that's an important place because that's where I grew up. So I have a lot of great memories up there. You know, you can debate over whether it's more civilized to be in some of these small towns or small villages like that, or maybe civilization itself is overrated. But I think it's a great place to be. I have a lot of good memories of that area. Take a look at some other views, particularly off the Cap Rock, because those on the top are just pretty flat and not real scenic. But for instance, some of the sites in the area, there's a Blackwater Draw in New Mexico. We'll take a look at it. There's a couple of yellow dots. You can read them. There's we'll be talking about the Caprock Canyon and Paladuro Canyon, the Alabase Quarry up to the north, and we'll talk about each of these. This is a photograph of coming off the cap near Lubbock, Texas. And you can see the upper part on this is very flat with kind of a little cap rock around the top of it. It's made out of caliche, a limestone unit. And then you come down through pretty quickly into older rock down in below that. Here's another view in Paladuro Canyon, south of Amarillo. And it's really a pretty canyon. It's really the second most extensive canyon in North America, second to the Grand Canyon. Kind of bothers Texas to have the second largest canyon, but that's still just the way it is. It's not quite the Grand Canyon. The top on it is again very flat, and that's the Ogallala Formation, and we'll be looking at it in more detail. This is another picture just in the area of Caprock Canyon, which is south of Paladuro. And it's again, it has beautiful canyon areas in it and beautiful sights to see around it. And now I'm going to look at in the next slide at a cross section. It's going to be a north-south cross section, roughly going through Lubbock, Texas, coming up north through Paladuro Canyon and a little ways north of that. So that's where it is. And it's going to show what the rocks look like down beneath the surface. So you can get a feel for that. Really well known from both seismic and from many oil wells that have been drilled in this area. Okay, so this is the section we got to show gets to be about 10,000 feet of sediment up above the igneous rock there. The igneous rock would be in red. You see a series of highs in here up around Amarillo. There's Amarillo uplift. And then to the south, there's an arc called the Matador Arc. You've got about 10,000 feet of rock here, as I say, that has to be explained. Almost all of this would be, according to the young earth interpretations, would be part of the flood deposit. It had to be deposited within 1 year. And it's hard to put some of these things into a flood type environment. The green stripes up near the top in here are large salt deposits. And these purple crosses in here represent anhydrite. Anhydrite and halite or salt are typically deposited in arid environments, places like the Persian Gulf that we have today. A lot of evaporation taking place over a long period of time. Hard to see why you would see those type of processes evidenced in a flood deposit. This gets up into, this is all Paleozoic rock, the older rocks. Then there's a section of Mesozoic rock. In this case, it happens to be all Triassic. In some places in this area, you get some Cretaceous and Jurassic section. And then you get into the Pliocene up above that. You see that you come off of a flat area as you go to the north up in here, which is coming off the cap. That's the edge of the Llano Estacado. And then there's a canyon that's cut down in here, and that would be the Paladuro Canyon up to the right. The section we're going to look at in more detail is this, shown as a sand up in here, the yellow section in here, and there's a thin limestone that creates that cap rock up above that. And that is the unit that's known as the Ogallala Formation. Ogallala is just a name that I like as part of that. Please watch part 2 of this. We're going to examine the Llano Estacado in a lot more detail on that. We'll look at the Ogallala Formation. And there's a sand in it that's been interpreted by one of the leading young earth creation geologists, Dr. Tim Cleary, as being a sheet sand that was deposited late in Noah's flood. How valid is that interpretation? We'll look at that. We'll look at the unit on top of that, which is a caliche, a limestone that was developed in ancient semi-arid soil and extends across a huge area. Then we'll look at the Blackwater Draw Formation and see what human artifacts tell us about the period right after Noah's flood. So, as the song would say at the end of the Beverly Hills program, y'all come back now. Here